Okay, welcome, Robert, and welcome all of you who are watching this as an archive webinar. This is week 9 of the class. We're almost done. There's only 2 more webinars after this. Next week, we'll do Chapter 12, and the week after that, we'll do Chapter 13, and which is only part of Chapter 13, and mostly just a review for the final is the plan for the next couple weeks. I don't plan on this one being that long, so you probably don't have to stay even a whole hour. We'll see how it goes.
All right.
The plan today, though, is we're going to do something we haven't really done yet this quarter, and that's deal with qualitative data, true qualitative data. You know, data like what state were you born in? Okay, you can't take an average of that. It doesn't make sense to add California plus New York plus Florida and divide by 3. Okay, so we got to figure out how do you actually do statistics when you have a study on qualitative data. And you could do some, not all, but we'll talk about the different types of hypothesis tests, because that's what the whole class, at least the last half of the class, is all about. So we'll look at a hypothesis test on qualitative data. And the other thing I'll do, if you have any questions, Robert, I'm not sure how your project is going. Is it going all right?
That's one thing I had to start. My partner dropped the class.
Right. I kind of saw that in the discussion forum.
Yeah.
So you need a new partner.
Yeah.
You need a new partner. So hopefully, maybe I'll post something too, but you might want to post again. It's still a little early, so not everyone's looking yet.
Yeah.
Not everyone's looking yet, but pretty soon they'll start looking at Project 2 and the discussion forum. You might want to check. I know there's a couple partners who have already posted. I want to see if you can join them.
Yeah, I looked. I think a couple people that posted already had 3, or one of them, or at least already had 3. I'll check.
Yeah, if they don't have 3. If they already have 3, then but I'm sure there's some that don't have 3.
Yeah,
I know that because I graded the last project, and a lot of them did not have 3.
All right.
And some might be in the same situation you're in. Most people are still in the class, but there are a few people that have dropped. So anyway, do you have any questions?
No, I'm ready to go.
Okay. The other thing you can do is you can start thinking about your project, and then ask if anyone wants to join you. Say, hey, you've already started. You got a hypothesis test, an idea that's already been approved and can work. And then people might be wanting to join you if you've already started. Does that make sense?
Yeah, makes sense.
And if you join a pair that's already started and you've already started, you can, you haven't put a lot of time in and you can just move on. That's a possibility too. But you definitely want to work with a partner. Okay, so let me go and I'm going to share my desktop. And this is an interesting part of the course, is that we are not doing things that you're going to read in the news every day. We're past that, which was neat. Now we're getting into research. Okay, so I could show you things in research. Most of them do not have the full chi-squared analysis. They only have the results. So you tend not to publish the full analysis in research papers. You just say you did chi-squared, you give your p-value, and then you move on. And you don't do all the rest of it. Dominique, thanks for coming. We got Dominique and Robert. And I'm just going to move on to a chi-squared example. And these are, interesting examples. I have used chi-squared in my consulting work. I do some consulting work just mostly so that I can stay with it. Because if I don't, then I only know the theory of statistics and I don't really get my feet wet. So I like to do consulting work when I can. And chi-squared comes up quite a lot. Maybe even talk about that. So let me go to the first question. Let me find it. Okay, so here's the first question I've got. And what it says is traffic equally bad in the northeast, north, south, east, or west shore? So I always forget where everybody's from. Are either of you from Tahoe?
No. From San Jose.
Okay, so if you don't know Tahoe well, they kind of break it up in 4 shores, as you can see. And you've probably seen a map of California and know that it's a big lake. You know that, right? So the question is, which has more cars? Okay, are they all the same or are they not all the same? Does that make sense? So the first thing is what you want to think about is if you were going to do a study, you're going to do a count, you're going to look at the cars in the Tahoe area. And you're going to ask the survey question or collect the data. It's not going to be a number. It's going to be what part of Tahoe is that car at. And what you're going to jot down on a piece of paper is either north, south, east, or west. Is that clear?
Mm-hmm.
So notice that this does not fit with anything else we've done in this class. We've only been able to handle hypothesis tests where either the answer was a number, like how old are you, or the answer was yes or no. Do you remember that?
Yep.
Okay, this is different. Here, again, it's qualitative. And when you have pure qualitative data, not a yes-no qualitative, but pure qualitative, we can do some other things with it, and we're going to do what's called chi-squared analysis. So as you are used to, hopefully, at this point, because we've been doing a long time, is we start out with a null and alternative hypotheses, right? So this is going to be different. And I want to warn you, the two of you and everybody, some people, this is where they start blowing it on the rest of the chapters. And just because this chapter does it differently than the other chapters doesn't mean you can use this chapter's way for the other chapters. So this chapter, our H0 and H1 are going to be words. We're going to write a sentence. In chapters 9 and 10, and actually 12 also, we only use symbols, no words allowed. Do you remember that? You had like P equals 4 or mu1 equals mu2. You didn't do words. So in this chapter, we're doing words. So the problem that a lot of people have is that they get so used to words, they forgot how to use symbols in chapters 9 and 10. And then I give the final and I see a bunch of words. So I promise you won't use words for anything that comes from chapter 9 and 10. Is that a promise?
Yep.
Okay. Now I'll write down H0 and H1 now that you promised. So H0, and hopefully you're all promising, those of you watching this as an archive webinar. So the first thing is this first test that we're going to be doing is all about deciding whether the distribution of the data fits some known distribution. So what do we call it? We had a word for it in this class a bunch of chapters ago. If all of the data is the same, because that's what we want to find out. Are they equally bad in these 4 shores? Do you remember there was a single word that we used when everything was the same?
Was it uniform?
Yeah, uniform. Okay, so for this particular example, and I want to let you know we're checking for distributions. So a absolute requirement, you might want to take notes and write this down, an absolute requirement for this particular type of hypothesis test, which we're going to be calling a chi-squared test for goodness of fit, is that you have to have the word distribution. So let me write it out. The distribution of cars in Tahoe is uniform. It's very simple, but I will promise you, if you don't have the word uniform, you don't have the word distribution, I will take off points. Okay, it's not always going to be uniform. There's other reasons, other things, and we'll see an example or two of why you use a chi-squared distribution, a chi-squared goodness of fit, but distribution has to be there. Got it? So once you have H0, H1 is really easy, I promise. And that is the distribution of cars in Tahoe is not uniform. Any questions on that? Okay, so it's pretty simple to write them out, but please, the hardest part about this whole thing is to be able to look at this and know that this is the kind of hypothesis test we're doing. Because now that we have all kinds of hypothesis tests, You got to be able to fit it with the right chapter and the right part of the chapter. So I'm just going to write down the title of our test. And this is called a chi-squared, as soon as I can get to it, there, chi-square goodness of fit test. So chi-square turns out to be the distribution we're using. So we have seen other distributions. We've seen binomial. These should ring a bell, by the way. Uniform, normal, right? And what else? One more that had a single letter. Should I tell you? T.
Oh.
Remember the T distribution? So now this is our fifth distribution of our class. And this is called the chi-squared distribution. I'm not going to go into all of the fancy math. You don't need that to be able to succeed. But you do need to understand which distribution we're using, which test we're using. Okay, goodness of fit is because we want to find out if the distribution of the data that we've collected fits some expected distribution. In this case, the expected distribution is uniform. We're going to see, is it uniform? What are some other expected distributions you may need someday? What's the other biggie in this class?
Normal.
Normal. So remember we talked about the normality assumption? This is one way of deciding whether, bless you, by the way,
Thank you.
whether you have the normality assumption achieved or not. Is that you can, it turns out you can do this particular test and say that you don't have it achieved, is what you can say. Okay, the next thing I'm going to do is I'm going to make a table. So to do that, I think I need a pen. So I'm just going to write O for observed and E for expected. Okay, and then we had four shores, the north, south, east, and west. And we should put our numbers in. Hopefully I've put enough room for those. Make the text a little smaller because I'm really worrying about fit. Okay, so the first thing is let's put in the observed, and that's pretty easy because it's given. How many did we observe in the North Shore?
170.
Yeah, 170 in the North Shore. How many in the South Shore?
212.
Yeah. Uh-oh. I did not mean to do that. Try this again. I got to click T. 212. Okay. And then how many did we observe in the East Shore?
110.
Mm-hmm. And then finally, we had 108 in the West Shore. You're going to find this not too hard. Again, the hardest part is actually deciding that this is what we need to do. Doing it is pretty easy. All right, now comes the part that you have to think about a bit. This is the expected. So expected means H naught is true. So if we have a uniform distribution and we had 600 cars, how many would we expect in the North Shore?
150.
Yeah. And Robert, how'd you get 150?
600 divided by 4.
Exactly, exactly. So there's 4 different shores. There's 600 different cars. So if it was completely uniform, you'd do 600 divided by 4, and you'd have 150 in each. Is that clear? I think I can actually write it this way easier. Oh, shoot. One more try. That's better. So we have 150, 150, 150, and 150. Any questions on that? Sometimes that's a hard part too, is writing down the E. Okay, so now what I need to do is I need to go to my calculator. So the first thing I'm going to do is let's share my screen of my calculator. And used to this, I'm going to go to Stat and Edit. I need to clear out L1 and L2. And then in L1, I just type my observed. So if you remember, my observed was 170. And then 212. Oops, missed. And then 110. And then 108. In L2, I put my expected. Do you agree it's pretty straightforward?
Yeah.
So I go 150, except I missed. 150, 150, and 150. Okay, this is the point in the class where you have to cross your fingers and just really, really hope that your calculator is going to work. And if it doesn't, you're going to have to do a little programming. So follow along. Do you both have your calculators with you?
Yeah.
Good. Okay, don't forget to cross your fingers. So hit Stat. And then you're going to go to Tests. Hit the up arrow. It's a lot faster. And see this GOF. Robert, Dominique, do you have it on your calculator?
No.
Okay, bummer for you, Robert. Sorry about that. And you don't live here either. See, if you live here, you can come in and I can share it with you. But it's a physical, I have to take my calculator and take a cord and stick it into your calculator. All of you are watching. If you happen to, be in Tahoe, I can do that for you in office hours. I won't be here. I'll actually be driving through your area, I think. But at 4 in the morning on Thursday. So I won't be here Thursday and Friday, by the way. I have a meeting in Lemoore. And Robert, were you one of those in Modesto too?
No, I'm in San Jose.
Oh, you're in San Jose. You're not Modesto. Okay, I have a bunch of Modesto. Okay, so I'm not going through your area. But the point is that you're going to have to get it, and I'll explain a few ways of getting it.
Okay.
All right, but I'm going to show you this way, and that is you're going to go up to chi-squared GOF test and hit Enter. And observe should be L1. If it doesn't say L1, go second one and Enter. And expected should be L2. If it doesn't say that, go second 2 and Enter. Degrees of freedom are the number of categories minus 1. Can you remember that? So in this case, there's 4 shores, right? North, south, east, and west. Minus 1 is 3. So the degrees of freedom is 3. You don't need a calculator to do that calculation, but you do have to remember how to do that. Color, I really never care. And should I move on? Hit Enter. Okay, so here's what we got. Chi-squared is a test statistic. Just a note, this is a Greek letter, it's not x squared. It's actually called chi-squared, C-H-I. And that's 50.72. The next number is the most important, and that is the p-value. How do you read this? How do you read this p-value? Here's the hint. The p-value is not 5.6. Either of you see it?
It's like
A really small number.
Yeah, it's 0.000000000056. Is that clear?
Yeah.
That E negative 11 means move the decimal over 11 places. Okay, and that happens from time to time. That's not this chapter, that's all chapters that you've seen that, right?
Yeah.
But just pay attention to it. Just to note, P can never be greater than 1 because it's a probability. So if you wrote 5.6, that means you're saying you had a 560% chance. Well, that doesn't even make sense. Is that clear?
Mm-hmm.
So this p-value is ridiculously small. Any questions so far? Okay, so now I'm going to go to new share. I got my super small p-value. That's what I was interested in looking at. And now I can go ahead and write down my conclusion, and you're used to seeing how the conclusion is written. If the p-value is that small, what are the first few words?
Strong.
How about there? Y'all remember?
Statistically significant.
Yeah, and I'm gonna write strong because it's super small. Evidence. And the nice thing is this is really easy to conclude that, and all I have to do is write down H1. The distribution of cars in Tahoe is not uniform. Any questions on that? Okay, just want to let you know something about this particular test. That's all it says. You can't go further with this test and decide how it's not uniform. Which one is more, which one is less. Maybe 3 are the same and the 4th one's different. Does that make sense?
Mm-hmm.
All you know is they're not all the same. And that's all you can say. There are other tests where you can actually decide how they're not uniform, but that's an advanced statistics class, which we don't do in this class. This is elementary statistics. So just let you know that if you continue and do another class in statistics at the university, then that's what one of the things you do next. Any questions on this? Not too bad, right? All right, let me erase this. Yeah. And let me move on to another example. Okay, so here's another example. A study was done to see if there's a difference in the distribution of cars for men and women. Of the 200 men surveyed, 70 owned a foreign car, 110 owned an American car, 20 did not own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 32 did not own a car. And conduct the appropriate hypothesis test and provide your interpretations. All right, here's the question I have. How does this differ from the last one we looked at? They're even both about cars, but that's not really what I'm talking about. What's different in terms of the data?
There's 2 samples.
Yeah. So in the last one, we had an unknown distribution, the distribution of cars in Tahoe, in terms of where they are, and then a known distribution, uniform. And we're comparing the unknown with the known. Do you see that? Here, we have an unknown distribution, and that's the distribution of types of cars for men, and another unknown distribution, and that's the distribution of types of cars for women. Is that clear? And we're not comparing the known to an unknown, or an unknown to a known, we're comparing an unknown to an unknown. Is that clear? So this one's different. It's a different test, but it's going to look pretty similar, except the calculator is going to be very different. And the good news for you, Robert, is your calculator will be able to do this one.
All right.
Okay, so as always, start with H naught. And very similar, that word, remember I told you the one word you have to have? What was it?
Distribution.
Distribution. In this case, it's slightly different. It's plural. Distributions. So the distributions of car type are the same for each gender. Is that clear?
Yeah.
And then H1. Notice this isn't about uniform. It's one being the same as the other. So H1 is the distributions of car type are not the same for each gender. Is that clear? Okay, this is going to be a different test than the one we had before. And the name of this test, it's also a chi-square test. It uses that same distribution, but it's a different test because we're comparing two distributions that we don't know about. This is called the chi-squared test for homogeneity. Have you heard that word before, homogeneity? Have you heard of homogenized milk?
Yeah.
Same idea. So homogenized, you know what that means? Either of you know?
Mm-mm.
So a test for homogeneity is to see if it's all the same, right? And that's what homogenized is. It's all in there the same, right? It's all white when you drink milk, unless you're having chocolate milk. But it's all the same. So we're checking to see if it's all the same or is it different. Okay, homogeneity means the same. Heterogeneity means different. I don't know if you've heard those words before. Okay, they actually they use it for sexual preference, right? I don't know if you've heard that before, but same roots.
Makes sense, yeah.
Yeah, so it's the same root. It's an English word. Okay, it's not a math thing. Chi-squared is math, though. Okay, so now what we're going to do is we don't have an observed and expected anymore. Now we have observed and observed, right? Do you see that? So in this case, we're still going to draw a table, but it's going to look a little different because, again, it's not observed and expected. And we had, let's see, foreign, American, and none. So I'll just write down some letters for this. Except I missed. How about F, A, and an N? Looks like a fan. Foreign, American, and none. And then we have male and female. One more try. Okay, and then we put our numbers in. We have 70, 110, and 20. for the males, and then for the females, we had 110, 158, and 32. Any questions so far? All right. So now you're used to it. What do you think the next step is?
Test.
Calculator. Yeah, we use our calculator. So hopefully you're all convinced that calculators are really, really, really important in this class. Okay, they pretty much didn't even teach this class. This wasn't even offered before there were calculators.
My batteries actually ran out during the midterm.
That's not good. So I don't know if you remembered, but in my discussion about the midterm, remember I told you what to bring?
I brought batteries.
Oh, you did. So they ran out and you got new ones.
Yeah.
Oh, good. Yeah, always bring extra batteries. And for the final, even more so. Okay, so we're going to go to the calculator now. Let me go grab it. Let's just clear what we had. Now I'm going to go to stat. I'm not going to go to stat. This is actually different. This is actually very different than anything you've seen before in this class. We're not going to stat. We're not going to enter these into L1 and L2. We're actually going to enter it into what's called a matrix. Second matrix. Any questions on that? And then go to edit and enter. Now, the matrix that we had, it had, if you remember, 2 rows and 3 columns. There were 2 genders, 3 types of car ownership. So 2, and then you can use the arrow by 3. And that allows us to put the numbers in nicely. So now we put our numbers in that we have. So we had a 70, enter, then we had 110 and 20. And then we had 110, 158, and 30. Any questions so far? Okay, so this looks really different than what we've ever done before, but it's just the way the calculator works. Then I'm going to go to stat, tests, and use the up arrow because it's a lot faster. We're not doing a GOF test. We're doing just a chi-squared test. And all the calculators have that one. It's weird that about halfway through the second year, I think, of building TI-84s, Texas Instruments put in the GOF test. I think they realized that they needed it. But the chi-square test they've always had. I hit enter. Just observed is A, expected is B. And then enter and calculate. Any questions so far? All right, notice that the chi-squared is 0.2658 or so, and the p-value is 0.89 or so, 8756 if you were sticking in the computer. So what do you think with this p-value? What does that tell you?
It's huge.
It's huge. And when it's huge, what do?
Failed to reject.
You fail to reject, exactly. Hypothesis test is very systematic. It's very consistent. The p-value is everything. Hopefully you're getting that at this point. We're going to see that even for the next couple of weeks. We'll have p-values every time. Okay, so now I can go and do my new share and go back to where I was and can write down my conclusion. And hopefully you know the first couple words I'm going to write. What are they? There is
Insufficient or statistically.
You could say insufficient. I like to write statistically insignificant or insufficient. You should understand both of them because you'll be tested on both of them, especially on the computer. Statistically insignificant. Significant evidence. And the way I like to write it is to make a conclusion whether or not the distributions of car type and if you write it with the whether or not, you can choose either because whether or not is both sides, right? So are the same for each gender is fine. You could also write not the same as long as you write whether or not. Any questions on that?
Will these problems not give the level of significance?
I'll tell you, if you get p-values like that, then you don't need a level of significance.
Okay.
And in the real world, no one gives you a level of significance.
Okay.
So sometimes I don't on purpose because when you get out into your upper division coursework, you're not going to be given a level of significance. You're just going to have to understand the p-value.
Okay.
Does that make sense? I don't remember your majors, but you'll probably see p-values. What was your majors?
Psychology.
Business.
Definitely. And what about you, Robert?
Business.
Business, yeah. So both of those fields definitely do hypothesis testing and p-values. And typically, psychology always uses 5%, by the way. Business, you know how business is. It's whatever they feel like. But psychology, it's very consistent at 5%. I don't think I've ever seen any psychologist ever use anything other than 5%. That's just their standard. So for Dominique, it'll be 5% for you. And 95% confidence intervals is standard. Okay, so any questions? Any questions on this? Okay, let me give you the third type. There's actually 3 types of tests. Time. There we go. Okay, and this one, I'm not sure. I never know if it's actually going to do it nicely or not. Just a second. I'm going to be copying a table, so I don't have to do it. I think it's going to work. We'll see. Yeah, came out nicely. Okay, so is there a relationship between the day of the week a person is born and the type of smartphone they own? Okay. The table below shows the results of a study that was recently done. Conduct the appropriate test and provide your interpretations. So notice that the survey question is what day of the week were you born? So Dominique, what day of the week were you born?
I have no idea.
I get that a lot. How about you, Robert?
I think I was born on Wednesday.
Good. Notice you didn't give me a number and you didn't say yes or no. Did you see that? All right. And how about this one, Dominique? What kind of smartphone do you own?
iPhone.
iPhone. Okay. So again, you didn't give me a number. You gave me a word. Okay. This chapter is all about dealing with qualitative variables. And here we have two different survey questions. And what we want to do is we want to say, is there an association between the two or not? And the word we're going to use is independent. So the first thing is let's write down, as you're used to, the null and alternative hypotheses. And for H naught, just like for the other two, there is a keyword that you must have. And that is, any guess?
Distribution.
Nope, that was for the other two, but it's a good try. That's what I just said. That's a hint. Independent. Okay, so what we can say is a day of the week a person was born. I'll just call it of birth. And smartphone type are independent. Any guess on what H1 might be?
Or not.
You could say not independent, but what's a simpler way to say not independent?
Dependent.
Dependent. Okay, that's a little easier. Day of the week, birth, and smartphone type are dependent. Any questions on H0 and H1? All right, this hypothesis test is going to have a name, and it's called a chi-squared. It still uses this chi-squared test for independence. Any questions on that? All right, so again, this is a test to find out if they're independent or dependent. And the good news is, in terms of the calculator, we do exactly the same as what we did for test for homogeneity. Okay, except you're going to have 3 rows instead of 2. Hopefully that's obvious, right? So I'm going to go to my calculator. Clear what we had. I'm going to go to second matrix. And then I'm going to go to edit. It's not 2 by 3 anymore. It is 3 by 7. Any questions on that so far? And now I type the numbers in, so let me do it fast. 75, 72, 68, 77, 70, and then 86, 80. And then we had 120, 111, 131, 125, 118, 124, 101, 45, 52, 44, 50, 57, 46, and 52. I'm not sure if you all remember, but do you remember in chapter 3, we talked about whether 2 things were independent or not in probability?
Mm-hmm.
Yeah, it turns out that there's an observed and expected, and you use the same formula for independence that we had in chapter 3 to get that expected. But the calculator is going to do all that work for us. But I figure I should tell you that the math is actually the same, even though you're not going to see it, because the calculator does the work for you. It's very tedious when you have, say, a 3 by 7 table, because it's going to be 21 calculations. So it's much nicer when the calculator just does it, isn't it? But the math turns out to be the same as that chapter 3 independence. It's not just like using the same word for totally different things. They actually have the same meaning. But this is the independence for the entire group, whereas we only looked at two things, like Android and Saturday, to see if they're independent before. So now we're looking at all of them, and that's the difference. But the math turns out to be the same. Any questions so far? Okay, so now that I've got that, again, my promise was this is exactly the same mathematics as the test for homogeneity. H0 and H1 look very different, right? You have the word distributions for homogeneity, we're talking about independence for test for independence. But if you remember, we got a stat, test, you go up until you see chi-square test, hit enter. I'll slow down because I was going really fast. Observed and expected are still A and B, color I don't care about. And I hit enter. Wonder if I had a typo there because I don't remember this p-value.
I was going to say, I don't think I got the same thing.
Yeah, let me look at my matrix again. Sometimes this computer does not hit all the keys that I want to use. Here we go. 75, 72, 68, 77, 70, 86, maybe 80, 120, 111, 131, 125, 118, 14. There it is. That was supposed to be 124. One little mistake like that will get you. So let me go back to my matrix. And let's go to edit. And that was supposed to be 124. And then I should get what I should get. Much better numbers. So I'm going to go to, it's not second, I'm going to go to stat. Let's get, go to stat. Tests. Chi-square test. And that's better. So yeah, typo will get you. Okay, so notice chi-squared is 9.0, and the p-value is about 0.6978. Okay, which you probably wouldn't expect a big p-value because do you really think day of the week you were born and type of smartphone have anything to do with each other?
No.
Probably not, unless you're one of those that like completely believes in astrology, right? You know, where the moon was when you were born and has the rest determines the rest of your life. Statistically, they've never shown that works actually. Okay, so what we get is a p-value is about 0.6978. That's really big. So now we can very easily come up with our conclusion. And what we say, and hopefully you know the first few words. There is, what do we say?
Statistically insignificant.
Yeah. Evidence to make a conclusion. Whether or not day of a week of birth and smartphone type are independent. And again, if you use the word whether or not, you could also say dependent. It means the same thing. Is that clear? Okay, not too hard, is it? All right, I think I can do one more and then we'll call it a day. Sound good?
Yeah.
This is going to look a little different, but it turns out it's not that much different. So let me get rid of this last one.
Do we use the chi-squared number for anything?
That it's kind of like the test. That is the test statistic. So they're going to ask you to put it in. So if I ask you for it, that's what you're doing. What I do a lot of, and maybe you don't like it, but I apologize if you don't, is I throw a lot of the heavy math under the table or under the carpet. And really, because you need to have calculus to really understand all this stuff, and calculus isn't a prereq. So I want you to like be able to write down the number, but you don't have to completely understand it because there's some severe calculus going on here. Really hard calculus, it turns out. Okay, and I don't know if either of you have had calculus. Have you?
No.
Dominique, you have?
Yeah.
Okay, so I don't know if you realize, but this p-value is area under a curve, right?
Okay.
Do you remember that? Integration?
Yeah, it's been a while.
Okay. And you do that with integration?
Okay.
There's formulas for all, like chi-squared and normal and t. There's formulas for all that. And then there's integrals to get all this stuff. But we don't do that in this class. So it sounds like, Dominique, you're even happy that we don't, even though, because it's been a while. But you did that at one point in your life, right?
Mm-hmm.
Yeah, and Robert, you never did because you never had calculus. So we shove it all under the carpet and let the calculator do the work for us. Sound good?
Yep.
But I do want you to just write down that test statistic. Okay. It turns out that the chi-square distribution, maybe I'll even draw a quick little picture since you asked. You kind of asked. It looks like this. It's got actually two types. Usually it looks like this. Okay, it's not quite normal. Do you see that? One of the big differences is it's never negative. And when you square something, you don't get a negative value. So it has to do with that. I'm not going to give you the formula. That's too much. But I can show you a picture. So then the test statistic might be, say, this value right here. And that would be your chi-square test statistic. And then the p-value is this area to the right. Does that make some sense?
Okay.
Okay, so that's what's going on with that chi-square. That's the number. The number tells you where you are on this curve. Okay, I'm not going to do any more math than that, if that's okay with you guys, because I'd need to do calculus at that point. And if you want to learn about that stuff, then you definitely have to take calculus and then become a math major or a mathematical statistics major. And then you'll learn about that. But we don't do it. All right, so let's go ahead and let me do one more example. Get rid of that picture. And let's do another example. This one. Oh, this isn't the one, just a minute. This one. And I'll even let you get away with not knowing what a Steller's J is. Do you know what one is? You might know anyway.
No.
No? They call them, most people call them blue jays, even though they're not blue jays. When you go up in the mountains and see those really pretty blue birds, they're kind of noisy. Those are called Steller's Jays. That's our main bird up here. So 70% of all Steller's jays nest in pine trees. 20% nest in aspen trees. And the rest nest in other places. A biologist has observed 250 Steller's jays that were given a special strength gene and then tagged to see if the distribution is different for Steller's jays with that gene. 201 of these tagged Steller jays nested in pine trees, 39 nested in aspen trees, and the rest nested in other places. Let's conduct the appropriate hypothesis test. Okay, so the first thing you have to decide on is what kind of test is this? What do you think? And as you might guess, it's one of the three we've dealt with already today. Which of the three is this? What do you think? So I'll give you the three choices. I'll do them in order. There's goodness of fit, homogeneity, and independence. And it is one of those three. And if you get the wrong test on the final, for example, you lose a lot of points.
Goodness of fit.
Do you agree, Dominique?
I was gonna guess the independence. But...
Okay, turns out Robert was right. As good as a fit, because here we know the distribution for regular Steller's J's, right? We have a known distribution for these regular J's in the population. And what we did is we took a sample of these special, GMO birds, right? And we only have one sample. Do you see that? And in that sample, it's qualitative. So with independence, there's 2 survey questions. And here there's only one, and that is, what nest did you nest in? Right? All of our sample, they're all the GMO birds, right? But they have different nesting places. So this is one qualitative variable with a known distribution that we're comparing it with. So that's the first thing to do, is figure out what kind of test is it. Is that clear? Or did I still confuse you more?
Okay.
Okay, so let's write that down. This is a goodness of fit test, chi-squared goodness of fit test. And now I'm ready to write down H0 and H1. This is not about uniform. We're not trying to show that they uniformly are nests, because we're trying to show they're the same as the distribution. So we can say is that H0 is that the distribution of nesting places for, I'm going to call them GMO birds, is the same as the distribution for regular bird Jays. And H1 is the distribution. So let me copy, let's see. See if I can copy and paste it in. It does, good. And then all I have to do is say the distribution nesting places. So what word do I have to add in? There's only one word I have to add in.
Not.
Not. So is not the same. So that's a good thing about typing, is I can copy and paste it really well. Any questions on that? Okay, so now what we need to do is we need to get our observed and expected. So let me go and make a table. We have, we got the pine, aspen, and other. We have our observed, and we have the expected. And then for the observed, I can put in our numbers. We had, how many in pine? We had, where were we? 201. And then we had aspen trees. That was 39. How do I get the other?
Minus 250.
Yeah, I had 250 total, and I'm already up to 240, so there's 10 left. Any questions on that? Okay, now I got to get the expected, and we're going to do it in a similar way. Well, if regular jays, 70% of them nest in pine trees, and we observe 250 Steller jays, how many we expect in pine trees? How do you figure that out?
20 or 70% of 250?
Yeah, 70% of 250. Is that clear? And what's 70% of 250?
175.
175. Oops, in fact, I better hit text first. And then similarly, 20% of 250 is 50. And now the rest, we've already accounted for 225, right? And we want 250 total, so there's 25 left. Any questions on that? Okay, so now, and in fact, I think I better write this down since this one I don't have in front of me. So this is 201, 39, 10, 175, 50, 25. And I go to my calculator. Go ahead, hit share screen, clear what I had. Now we're good as a fit, so now we're going to put it in the stat, remember? Oops, I want to go to edit, enter, clear out what I had. Okay, I do L1 and L2. By the way, you have to make sure all the expecteds are bigger than 5. That's the requirement for sample size. Just like we've had before with the yes-no question. It's bigger than 5 for expecteds. Okay, so L1 is 201, then 39 and 10. L2 was 175, 50, and 25. Any questions? I go to stat. I go to tests. I go up to GOF. Sorry, Robert. But I'll show you if you want later the where you can find the test, where you can program it in. There's a YouTube video that shows you how to do it. I hit enter. L1, L2. The degrees of freedom, what is it this time?
2.
2, because we had 3 categories. 3 minus 1 is 2. And I go calculate. Okay, notice a tiny p-value, right? So these GMO birds are very different. Does that make sense? So now I can go ahead and type that out. And maybe I'll even write down there is sufficient evidence. I haven't used that word, so I might as well. To conclude that the GMO or the distribution of nesting places for GMO birds is not the same as the distribution for regular jays. Any questions on that? Okay, let me give you the secret word, which for this one is, write it out. Independence. Okay, we learned about a test for independence. Okay, and while I'm here, I think it's a good idea, Robert, if you see where to get this program. Mm-hmm. And either of you have questions, we're kind of done. Again, I'm not going an hour and a half like I have in the past. We're pretty much done, but for Robert, I better show you where to find it. So let me go and put this over here. Just a minute, I have to get my screen right. And then I could do new share. Oops, not yet. Cancel that. Just realized I had it on Gradebook, which you're not allowed to look at. That's better. All right, now I can look at my screen. Okay, so if you go to the syllabus, do you see? Do you have an 83 or 84?
83.
83. Okay, so this works on an 83, supposedly. I've only done an 84, but people have told me it works on 83. And, sorry, I think I had it in the modules, actually. That's right, I have it in the modules. One more try. And see, it says program GOF into the TI-8384?
Yeah.
If you click that, and this is an 8-minute YouTube video on how to do it.
Okay.
And what you have to do is hit every single button this person's. I didn't do this. This is somebody who made this video, and they did a great job. And if you hit every single button that this person hits, then it should work for you.
All right.
Okay. And then when you use it, you're going to go to program. You're not going to do the same thing. You're not going to go to stat and then GOF. You're going to go to program GOF. So that, you know, how to use it, it's actually easier, it turns out. But you have to do this first, which is a lot of work. And you have to get it just perfect.
Okay.
Okay, so I'll let you watch that. Okay, and all of you who have an 83 or an old version of 84, this is the video, and it's, again, in the modules, in this week's modules. Are there any questions?
Nope.
Nope.
Okay. Just note, I think it was you, Robert, that suggested we have it next Wednesday instead of Monday.
No.
Huh?
I think it was Thomas.
Oh, it was Thomas. That's right. It was Thomas. So the way I work it, if someone asks and no one says no, then that's probably what I'm going to do. So again, we'll take a look and, you know, see when you want the webinar. We only have a couple more, but I can definitely do it on that Wednesday instead of Monday if you want. But you can make suggestions. Post in the Q&A forum is where it's posted. So you're welcome to chime in and see. But well, it's kind of, I'd look at it as a vote. If I get 2 people that'd rather have a different time, I'll do the different time. But if no one else says anything, then it'll be Wednesday at 5.
Okay.
Okay.
Okay. And so it's good to move it around sometimes. Okay. So if you have no questions, we could say goodnight. But if you do, I'm always happy to answer questions that you might have.
Cool. Thanks, Professor. Have a good night.
Okay. You have a good night too.
Good night.
Good night. And for all of you watching this as an archive video, have a good night, and please post on the Q&A forum, and please look at the project discussion forum. Again, some of you need a partner. It's a good place to go find a partner if your partner dropped, or you only have 2 and you can add one, add somebody in, be nice. And until then, I'll be checking the Q&A forum and happy to answer questions in the project discussion forum. So take care. Good night.